going to be talking about moments. And a moment is a force, but now we're talking about rotational movement. When we talked about straight forces, we were talking about a straight push or pull. Now we're talking about something that's being rotated or twisted. For example, like the wrench turning this bolt right here. The force is pushed out here, and it turns this in a rotational manner. This may look familiar to you from when we did simple machines. Terminology we need, that's the force, and that's F. That's our pivot point. We often call that like the fulcrum or the center when we were talking about simple machines. And that's the distance. And this is super important. You need to write this down. The distance must be perpendicular to the force. I can't tell you how important that is. You will get it wrong if you don't get the distance going this way that's perpendicular to that force every time. And the moment is equal to just the distance times the force. You need to pause the video and copy this down. This is our units that we're going to be using. Remember, pound, this is pound force as compared to pounds mass, and that's for our English customary units. Also notice this is pounds dash feet, not pounds per foot, but pounds dash feet. Remember, it's force times distance, so here we're saying pounds times feet, or newtons times meters. I think everyone's familiar with clockwise and counterclockwise. We used it when we talked about gears and stuff before. You use it in geometry. If you don't know this, you should write it down. And now we're going to talk about right-hand rule. This is one way to remember when things are positive and negative. I'm going to show you two different ways. But in engineering, you'll hear a lot about the right-hand rule, and you'll also hear about several right-hand rules in physics. So you may want to write this down, and then we're going to show you some examples of what this means. But what we're saying is if the motion of, for instance, that wrench is going counterclockwise like this, then it's a positive moment going in the direction of your thumb. So here's an example. If we're turning like that, you would put your right hand where your fingers are going in the direction of the motion, and your thumb is pointing towards you. That means that it's a positive moment. Here's another one. Point your right hand in the direction that that motion was going, and you'll notice that the thumb is pointing away from you, which means that it's a negative moment. So let's do a problem example. So you should copy this down in your notebook and then work along with the video. Pause and rewind as you need. We have a wrench, it's 9 inches long, and we have 20 pounds of force out here at the end. So our formula is moment equals distance times force, 9 times 20. And it says to use this, and I'm going to show you another way to do it. So here's our distance in feet. And notice they changed this over to feet, because in our table we used pounds feet as the unit, not pounds inches. They used the right-hand rule and decided it was negative, but I'm going to show you another way in a second, and they multiply this out to get the moment is 15 pound-foot, or we could say clockwise. This is the way I think about it from a math standpoint. Starting here, this 9 inches is in the positive direction, and this force is in the negative direction. What's a positive times a negative? Well, that makes a negative here. So you can either use one of the right-hand rules we just talked about, or you can use a coordinate system, an X and Y axis, to think that's in the positive direction, that's in the negative. Positive times negative makes a negative. Now let's do a different problem. Now we have a longer distance. Is that going to make a bigger moment or a smaller moment? Well, here's our formula. It's already in 1 foot, so I don't have to convert it over. Again, this is positive and negative, making it a negative problem. And we get negative 20 pound-foot. You should be working along with these problems as you go. This is a really important one to realize. So we have this L-shaped wrench, and sometimes they have wrenches that look like this so that you can get into tight places, for instance in a car motor or something where it's hard to get in with a wrench. But here we're going to put the pounds right here. So when I work this out, am I going to do 20 times 1? What's wrong with that? Well, the problem is that those two are not perpendicular. We really need this distance. That's the distance that's perpendicular to this force. So really I need to convert the 3 inches over to 0.25 and then use my moment, force times distance, and getting negative 5 pounds of force. Again, this is in the positive Now we also have wrenches that are shaped like this. Again, these are used for getting into hard to reach places. And here they give us these dimensions. Which dimension do I need to use for the distance? Which of these three do I need to use for the distance in my moment formula? Well, remember I need to use the total perpendicular distance to the force. So that's this 18 inches here, which makes 1.5 feet. Put it in my formula, and we get negative 30 pound-foot. Our next problem looks like a wheel and axle, but let's see how this relates to moments that we talked about. There's our force, and there's the radius of the wheel. And here we're talking about metric units, so we're going to convert everything over to meters and newtons. And again, in this case, we have a negative radius and a negative force, making it a positive moment, making it 50 Newton meters. Now, what if, instead of holding the wheel and turning it, what if we just attach like a rope to this, because we want to sit over on the edge of our boat and be able to steer the boat from the angle. So here, again, here's our radius going straight out, and this is the first time we're going to see changing over to use our vector forces with our moments. We use this just like we did with the vectors. I need to find the portion of the force that's perpendicular to my radius. So I'm going to use the same kind of formula we did when we did the vectors to find that the force in the y direction is just 76. It's not the full 100 newtons that I was pulling on the rope. Change the radius over to meters, plug it in my formula, and we get our answer. Remember to pause and rewind as you need for the video to take these notes down. Okay, we're going to pause here and we're going to pick back up with this with part 2 of the video.